Hello friends, welcome to the new session where I'll be covering data frames. So data frames is part of a Pandas data library. So you will have to import Pandas as PD to actually access data frames. We'll be working with the same file that we used in the last example of dictionaries customer data. Let's just have a look at that file for a sec. Let's open the terminal and just have a look at this file customer data.txt so that we can see what data it holds. So now this data is like customer ID, name and some amount. So that is the data set that we are working with. As I showed earlier that I have a function which can read the data as a list. So let's do so. So a variable will be created. Now our data is in a list. So now we'll show three ways to create a data frame. Data frame can be created through a list, through a dictionary, and directly through a file. The obvious way is to do it directly through a file. But let's have a look at list first. So now this is not the data that we can work with. We just have an array kind of list. We want to convert it into a list of arrows. So what this command will do is convert into a list of array. Now let's have a look at the data. So now our data is a list of list or a list of array. So 0 in itself is a, so now we have a list of array. Now a data frame is actually like a spreadsheet or like a table. So we need the header for that table. So basically the column names, I can specify the labels here in a list that creates our labels. The next step is to create a data frame. We from a list we have to say df equal to pd dot data frame from records and data, and we need to just say columns equal to labels. If we don't do so, let's see what happens if I don't do that. So right now our df does not have the column names. That's not what we are trying to do. So let's just create it with column names. So now we have a data frame which has column names, customer ID, name and amount, and these values are the index. So df.ilock, using index location we can access any record, say the fifth record, so we can see the whole record like this. Now let's do one thing. Let's just run the last command by not having the labels or the headers. So now the data headers are only 0, 1, 2. Now we can just say df dot, and right now our labels are, so we can say df dot columns equal to labels, and now our df has those column names. So this is a way you can change the column names. The next thing to look at is df dot data types. So right now all the types are object, wherein we can see amount is like a number, right? So amount is a numeric value, and we could perform such operations on numeric value. So suppose I just select df amount and say sum. Right now it is saying it is an unsupported operand because I'm trying to sum up. Basically amount is right now object or string, so we need to just change the data format for that. So if we write something like df equal to df dot apply pd to numeric, so the whole we'll try to cast it and each and every column, and I have given ignore errors, so wherever it can't cast, so obviously it can't convert a name to a number. So by giving this argument we can ignore such errors. So now if we run and see the data types, you can see the amount has become an int 64, and now our sum will work. So this is how we can create using a list. Now we come to a dictionary. Now let's first create an empty dictionary and say add these 3 keys to that dictionary. So now we have a dict data. Let's have a look at dict data. Dict data is there. Let's first delete dict data. Actually, I would have created earlier. So if I run this now, how does our dict data looks like? Okay, it's adding all the names. So it has added all the amounts here, customer ID here and name here, because I have just used the data. So if you see the data right now, I had the data in this format and I have added it here. Now this dict data, these will be the labels in our data frame and these will be the values, and we need to be sure that all the lengths are same. So if we see here dict data amount length, similarly let's see the name length and the customer ID length. So let's print the customer ID length also. All are 6. Now we can directly use a command in Python to create a data frame out of this dict data. So let's just run it. We'll get a data frame. So now we have a data frame like this. Here d types. Obviously it has again become an object. So let's just now we can play around with the data frame also. So if you see right now, the first column is amount and customer ID and name. Basically I can rearrange. So this is like I'm using the existing data frame to create a new data frame. Since I have assigned it to the same variable of data frame, it will just rearrange it for me. So if I run this command, you will see that customer ID has moved as the front row and name, and I can even say limit it to, let me just create a df1 equal to, let's copy this, let's say we are just interested in the customer ID and amount, and now I have a df1 which was created out of df. So I can select few things out of that also. I can even concatenate. So let's say df1 equal to, I can say, now this is where it might fail. If my data type of amount is integer, it will fail. So my data type is still a string for amount. So let's see how df1 looks now. So now you can see it has concatenated both the values. So that's how we can play around, and I can run the df. Now df d types correct, and if I run that same command here, it will fail now because the data types are different. So anyhow, let's moving on. So these are a few ways using which you can actually create data frames, which is through a list and through a dictionary. Now the most obvious way is to just directly read a